Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. This video will be part 1 in our checkout series on the Cessna 172. In this video, we'll do an overview of the aircraft systems and flight instruments. This video will focus primarily on the 172 Classic or steam gauge version of the aircraft, which is only available in the deluxe edition of Flight Simulator. I will do a quick overview of the system differences on the Garmin G1000 equipped aircraft in this video, but I won't be going in depth on the G1000 itself. I'll be doing a separate video series on the G1000 panels, so make sure to keep an eye on the channel for that. I also have a separate video on using the autopilot on this aircraft and a video series on using the Garmin GNS 530 and 430 GPS receivers this aircraft is equipped with. I'll leave a link to those videos in this video's description as well. I'll be conducting this lesson as differences training from the Cessna 152, so if you're unfamiliar with the 152 or new to aviation or flight sims in general, I recommend you check out my videos on the 152 systems and cockpit instruments. I'll leave a link to those videos in this video's description. Those lessons cover the fundamentals on how most aircraft systems and instruments on light aircraft work, and I won't be going in depth on those topics in this lesson either. So let's take a look at the Cessna 172. The Cessna 172 is a single-engine, four-seat, high-wing personal utility aircraft often used for training, particularly for instrument training. The aircraft was developed in 1956 from the Cessna 170, a four-seat tailwheel aircraft. It was manufactured from 1956 to 1986, then ceased production for 10 years. It resumed production in 1996 and remains in production to this day. More Cessna 172s have been built than any other aircraft, upwards of 44,000 units, and it has remained in production longer than any other type in the world. It has undergone numerous upgrades over the years, with each significant newer model receiving a letter designation. The model in Flight Simulator 2020 is a 172S, or SP, which was manufactured from 1998 and is the only model still in production. The exterior differences from the 152 are minimal, and most components are the same on both aircraft. Airframe design on the S model is a little more aerodynamic than in previous models or on the 152. Many of the sharp edges have been rounded out over time to reduce drag. Length, tail height, and wingspan are slightly larger than on the 152 to accommodate its larger passenger and baggage carrying capacity. All landing gear are equipped with wheel fairings or wheel pants to reduce drag. The little panels that you see in each wheel fairing is to access the tire for inflation and for checking inflation. There's a baggage door that is aft of the pilot's door on the left-hand side of the aircraft that gives you access to the baggage compartment. And the baggage compartment in the 172 is slightly larger than on the 152 and has two little kind of sub-compartments in there. The taxi and landing lights on the 172S are located on the left wing. This is so they don't have to shine through the propeller and get the strobe effect going at lower RPMs. The outboard light is the landing light, and the inboard light is the taxi light, and they're both tilted inward so that they shine on the runway in front of the aircraft. The power plant on the 172S is a Lycoming IO360. It's a fuel-injected engine like most modern cars, so we don't have to worry or pretend to worry about carburetor ice or carburetor heat, and there are no controls for that. The aircraft's rated horsepower is 180 horsepower. This is a good size engine for an aircraft of this size. When they first produced the 172, it was powered with a 145 horsepower engine, and that was a little underpowered for the size of the airframe. They eventually upped that on later models to 160 horsepower, which was adequate, but the 180 horsepower gives a nice amount of horsepower for the size of the airframe and the amount of weight that it can carry. The propeller on the airplane is a fixed-pitched tube-plated propeller, just like it was on the 152, so we don't have any control of the angle of the propeller blade from the cockpit. The diameter on the blade is slightly larger than that of the 152. It's about a half a foot longer. So let's take a look at some of the data for the Cessna 172. The aircraft, as equipped in Microsoft Flight Simulator, is certified for VFR and IFR day and night operations. It is, however, not certified for flight into known icing conditions. And this is true regardless of whether you're flying the steam gauge version or the G1000 version. It's also true regardless of whether you're flying the versions that are equipped with floats or skis. All the aircraft in Microsoft Flight Simulator are equipped and certified the same. The fuel capacity on the aircraft is 56 gallons. This is in two 28-gallon wing tanks. 53 gallons of that fuel is usable fuel, with 3 gallons being unusable, or about 1.5 gallons in each tank that is not usable. The average fuel burn is about 12 gallons per hour in Flight Simulator. This is a little higher than it is in real life. In real life, it's about 10 gallons per hour, but unfortunately, the fuel burn in Flight Simulator is a little bit higher. And this is at 5,000 feet, roughly, and standard atmosphere and normal cruise power, which in Flight Simulator 2400 RPM seems to work out pretty well for normal cruise power. The endurance in the aircraft with that fuel burn is going to be about 3 hours and 40 minutes plus a 45-minute reserve. And then the range on the aircraft is going to be about 400 nautical miles, again, plus a reserve, and that is in a zero wind condition. And then the service ceiling on the aircraft is 14,700 feet. And the takeoff ground roll, you'll need 960 feet from the time you put the power forward until you get the wheels off the ground. And to clear a 50-foot obstacle, total distance you're going to need for that is about 1,630 feet. So that's fairly comparable with the 152. Landing ground roll is going to be 575 feet from the time you touch down until the time you can get it stopped. And then to clear a 50-foot obstacle, total distance you'll need there is about 1,335 feet. Again, pretty comparable with what you had with the 152. And all of that is based on landing and taking off at sea level, standard atmosphere, and at max gross weight. Like many of the light general aviation aircraft in the game, it's fairly easy to find an aircraft manual for the 172 online. If you want to download one, make sure it's the manual for the 172S or SP, and also be aware that there are two different manuals available for the aircraft. The one designated as NAV1/NAV2 or having no designation are for the classic or steam gauge version of the aircraft. The ones designated as the NAV3 avionics option are for the G1000 equipped version, and the procedures are slightly different between the two versions, particularly for things like startup procedures. In addition to being labeled on the cover page, the even number pages in the manual also tell you which version of the manual you're looking at. If it says in the top right corner NAV3, that's for the G1000 aircraft. The steam gauge version will either say NAV1/2 or have no designation on those pages. So let's take a look at the weight and balance on the Cessna 172. In Flight Simulator, we have an empty weight for the aircraft of 1,691 pounds. The max takeoff weight, max gross takeoff weight for the aircraft in Flight Sim is 2558. That's actually the max ramp weight in real life. The max takeoff weight is actually 2550, but 8 pounds isn't going to make that big of a difference. That gives us a useful load of about 867 pounds. If we load up the aircraft with a full 28 gallons in each side of fuel, that gives us 336 pounds of fuel, and that's going to drop our max payload down to about 531 pounds. That gives us room to put three 170-pound passengers on the aircraft and about 21 pounds of bags or cargo, and still with it being within weight and balance limits. If we wanted to fit a fourth passenger on the aircraft, we're going to have to drop about 170 pounds of fuel, or about 28 gallons. So that's going to bring us down to about half tanks on the 172. That's going to make our range on this aircraft about an hour and 15 minutes plus your 45-minute reserve. You can see in real life why pilots say that this airplane, the 172, is a four-seat aircraft, but it's really realistically a three-place aircraft. In order to fit that fourth passenger on there, you're going to have to sacrifice a significant amount of endurance and range. And that's fairly true of most aircraft of this size and power in general aviation. Before we hop in the cockpit and take a look at instrumentation, there's one additional control we'll want to assign from the control menu, and that is toggle autopilot master. And you'll want to assign this not only for the 172, but for any aircraft that has an autopilot, up to and including the large jet airliners. And what this enables us to do is turn the autopilot on and off from this key or joystick button. I do recommend actually that you put it on a joystick button, preferably something on the stick itself. That makes it easy access. And the reason we want to do this, the main reason, is so that you have a way to turn the autopilot off if you're using an autopilot to fly an instrument approach and you get a visual on the runway. You'll want a quick way to turn the autopilot off and land visually, and that's what this switch does. So again, toggle autopilot master, bind that to something on the joystick, preferably. All right, so we'll hop in the cockpit and take a look at the instrumentation. Just like the 152, we'll do this lesson with the engine running and all the systems powered up so we can see how everything operates. One thing you'll probably notice about kind of the broad overview of the cockpit on the 172 is that everything you need while you're flying is pretty much directly in front of you. It's right in your line of sight. From the flight instruments to the engine instruments, the tachometer, and the nav radios, everything that you're going to need while you're flying, particularly flying on instruments, is right there in front of you. It's a little more compact a layout than we had in the 152. And again, this is a good setup for instrument flying, which is why these airplanes are used for instrument training, primary instrument training, a lot of the time. So we'll start at the top of the cockpit and work our way down. The first thing that you'll notice is where our outside air temperature gauge was in the 152. That's not there anymore. It's been replaced by a regular, albeit more modern, air vent. So that has been moved. We'll talk about that here in just a second. The magnetic compass is in the same place and works the same as it did in the 152, so that's about all I'm going to say about that. Our outside air temperature gauge has been moved to the left of the airspeed indicator, and it is now a digital gauge with quite a few more functions. It's more instruments rolled into one now. It's actually a voltmeter, outside air temperature gauge, clock, and timer, all in a single gauge. So let's talk about all those different functions. When you first boot into Flight Simulator, it will be in the voltmeter function. It just displays the voltage of the electrical system. Right now we're running off the alternator, so we're getting 28 volts. If I were to switch off the alternator though, it goes to show me the voltage of the battery. It should actually say 24 volts because that's what the battery is. I assume it drains down over time as you deplete the battery. And if I switch it back to alternator, it goes back to 28 volts. So that's just an indicator for the voltage there. If I press the top button once, it sends it over to outside air temperature in degrees Fahrenheit, and a second push will give me the temperature outside in degrees Celsius, and that is the temperature at your current altitude. And it is a functional gauge. If I go to the weather and I move the temperature back and forth here, you can see it does respond to that, so it is fully functional. The bottom portion is a clock and a timer. On the left-hand side, you have the 4 different modes it operates in, and that little black triangle tells you which mode you're in. The top 2 are clocks, the bottom 2 are timers. UT is Universal Coordinated Time, or UTC, also called Zulu Time or Greenwich Mean Time. It's the time in Greenwich, England, not adjusted for daylight savings time. It's a universal time that's used in aviation so that folks don't have to do time zone conversions for doing things like departure times, arrival times, and position reports, so that when we see a time on something like that, we know what time it is without having to do a time zone conversion. If you hit the select key, that moves between functions. That moves it over to LT, or local time. This is a local time clock displayed in a 24-hour format, so anything above 12 noon is going to be 13 is 1 o'clock and so on. So 14:38, right now it's 2:38 in the afternoon. Just like our analog clock in the 152, this will automatically set to whatever time you have your flight set when you boot up Flight Simulator, and if you change time zones, this will change automatically. There is no way to adjust those clocks, at least not that I'm aware of, in Flight Simulator. It's all automatically done for you. Going down to FT, that is flight timer. That starts timing in minutes and hours when you boot up Flight Simulator or when you load your flight. But you can reset it. Say if you want to measure how much time you've actually been in the air, or how much time it takes in the air to get from one point to another. Just hold the control down, and that resets it, and then it will start counting up again, so you can determine how much flight time you do between one point and another during a flight. The elapsed timer is a count up timer that counts in initially seconds and minutes, and then minutes and hours. To reset that, you hit the control and then hit control a second time, and it will start counting up. And again, seconds and minutes, and it gets past a certain number of minutes, it flips over to where this is minutes and this is hours. This is good for timing approaches. A lot of times you determine your missed approach point on an instrument approach, a non-precision approach, by timing it based on your ground speed, how long it takes you to get from one point to another. And when you reach the time that's in the chart, it's time to go missed approach. And so that's the functions of this gauge and what all those are used for. We'll set it back to, I guess, local time. So below our clock and to the left of the turn coordinator, we have the engine instruments. On the top left, we have the fuel quantity indicators. You'll notice they're quite a bit prettier and they have more demarcations, so they are more precise and more accurate than what you have in the 152. Down below that, we have our oil temperature and oil pressure gauges that work exactly the same as they did in the 152. They are, again, prettier and have more demarcations. Just like the 152, the oil pressure is going to show below the green band if you have the engine at idle, but if we push that engine above idle, you see it rises right up into the green band. And then to the right of that, we have a vacuum pressure gauge. This is the same as the suction gauge in the 152. It tells you the air pressure that is turning your directional gyro, your heading indicator gyro, and your attitude indicator gyro. And again, at idle, that's going to be below the green arc, but if you put the engine above idle, it will go ahead and rise into the green arc there. And then to the right, you have the amp meter, which shows you the charging status of the battery. I just started up the aircraft, so right now it is positive. That means the alternator is charging the battery. But if I were to flip the alternator off, we'll see that it goes negative. And we'll also, if we looked up at the annunciator indicator, we'll see that it gives us a low voltage light up there. And if I flip it back on, it again indicates that the alternator is charging the battery. So basically works the same as the 152, and it is working correctly now in Flight Simulator. So up above the amp meter and the vacuum pressure gauge, we have an instrument that has a fuel flow indicator on the right side that indicates your fuel flow that you're burning in gallons per hour. The demarcations here are 5, and then they're 1 gallon per hour increments after that, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. So this gives you a nice, good, precise indication of how much fuel you're burning when you're climbing and cruising, so you can do more accurate fuel calculations. To the left of that is an EGT, or an exhaust gas temperature gauge, which tells you how hot the exhaust is coming out of the engine. What you use this for in real life is you use it to lean the engine. What you can do in real life is lean until you get the EGT peaking and then start to come back down. And that tells you where the peak EGT is, and then you can use this little marker here to mark where the peak EGT is. And then typically the technique that most pilots in the real world use is once they find the peak EGT, they'll either go rich of that by 50 degrees, so they'll enrich in the mixture till it falls about 50 degrees, or some pilots lean it so they run about 50 degrees lean of peak EGT, and that's a big debate in the GA community as which one you should do, and one's more efficient, fuel efficient, but can be, I guess, harder on the engine. In Flight Sim, that doesn't work exactly like it should. If you lean the mixture, it will bring the EGT up, but before the EGT starts coming back down, you'll actually start to lose RPMs. So we have to use the technique that we used in the 152, lean it until you start losing RPMs, and then richen it up a little bit from there. So we can't use that. It does work, but it doesn't work completely accurate in Flight Simulator. We can't use it to lean the mixture. So up above the flight instruments, we have an annunciator panel. This is to let you know if you have a vacuum system failure, a loss of oil pressure, a loss of voltage, basically an alternator failure, or if you're running low on fuel. It's positioned up above the flight instruments so that if you are not including the engine instruments in your scan, it will draw your attention to a major system problem without you having to look at the flight instruments. Then you can take a look at the instruments and see what's going on. It is color coded, and this is a common color code to all annunciator panels. You usually have yellow, red, green, and sometimes blue colors in annunciator panels. The red is a major problem. That's something that's going to require immediate corrective action. A yellow means a problem that's going to require corrective action, but doesn't need necessarily immediate corrective action. Green means normal operations, and usually blue also means normal operations. And we do have a test switch over here that will test not only this annunciator panel, but also the annunciator panel for the GPS nav control up above the VOR radios there. And it has a dim switch, but I don't believe it works because it goes back to dim and then pops right back up, and it's the same brightness that it ever was. One more little oddity with the annunciator panel is that if you get your fuel low, if you get it low on the left side, it will only illuminate the L. I don't believe that's how the gauge actually operates. I think it should also illuminate that low fuel portion as well. If you do it on the right side, it does do like it's supposed to do on the real aircraft, but I believe that's just a little quirk of Flight Simulator. So the flight instruments are located on the left side of the cockpit, directly in front of the pilot, and they are arranged in what we call the standard instrument six-pack. It used to be when we first started putting flight instruments in aircraft, they were just put wherever there was space, and they were put in no particular order. But as pilots began to do instrument flying and instrument approaches, they noticed that there is a particular way you can arrange the instruments that is good for the most efficient instrument scan, and that's what we call the standard instrument six-pack. And that is with the attitude indicator in the top center of the instrument cluster, the airspeed indicator to the left of that, the altimeter to the right of that, and the turn coordinator on the bottom left, the heading indicator on the bottom center, and the vertical speed indicator on the bottom right. For the most part, the instruments work pretty much exactly like they did in the 152. In fact, the attitude indicator, the altimeter, the turn coordinator, and the vertical speed indicator work pretty much exactly as they did in the 152. The heading indicator is only slightly different. The two main differences is that your reference marks are red now instead of being white, so they're easier to see and distinguish from the actual headings on the indicator. And then you have this little red bug here that is controlled by this little heading knob here. This is a heading bug, and its primary purpose is to control the heading mode on the autopilot, but it can also be used as a heading reference bug. If you were given a certain heading by air traffic control, or you want to maintain a certain heading to fly your course, you can set this heading bug to that, and that way if you drift off the heading, you know what heading you're supposed to be on. So that's the difference with this. It's also not slave to the compass. It does have to be reset like you have to reset the one in the 152 as well. The airspeed indicator is a little bit different. The first thing you'll notice is that it is only in knots. There is no miles per hour scale on it. And then, of course, the V speeds are going to be a little bit different. They're going to be slightly faster in the 152. The markings are pretty much the same. We still have the white arc, the green arc, the yellow arc, and the red radial line. Then we have this little cutout down here and this little window up here, and this is a true airspeed calculator. So let's take a look at the V speeds for the 172, and let's talk about how that true airspeed calculator works. So the V speeds in the 172 are very similar to those in the 152. They're just slightly higher in most cases. VSO is going to be 40 knots. VS1 is going to be 48 knots. VFE is 85 knots for flaps 10 to flaps 30, but you can put down up to 10 degrees of flaps up to 110 knots. So there are two different VFA speeds on the 172. VNO is 129 knots, and then the red line VNE is 169 knots. And then the unmarked speeds, maneuvering speed or VA is going to be 105 knots, and that is at max gross weight. VX, or best angle of climb, is going to be 62 knots. That's what you'll use on your short field takeoffs and climbs. VY, or best rate of climb, is going to be 74 knots. And then VG is going to be 68 knots, so that is your best glide speed. As we mentioned earlier, this little cutout window down at the bottom of the indicator and this little window up top are part of a true airspeed calculator. So you can actually use the airspeed indicator to figure out what your true airspeed is. So let's take a look at how that works. So how this true airspeed calculator works on this airspeed indicator is that you have a temperature gauge or temperature scale at the top here that goes from negative 30 degrees C to plus 30 degrees C in increments of 10. And then you have a pressure altitude window here. So you want to line up your pressure altitude with the temperature scale up here, and that'll indicate your true airspeed down here. So we're at an indicated altitude of 5,500 feet. The altimeter is 2992, so our pressure altitude and our indicated altitude are equal. If you have any doubt, you can take a look at your transponder actually on the 172 Classic, and it will indicate your pressure altitude. But unless your altimeter is way off from standard, it's going to be pretty close to your indicated altitude, at least enough to be in the ballpark for this calculator here. So outside air temperature is 14 degrees C, so that's going to be about halfway between the plus 10 and the plus 20 mark there. So I'm going to try to line up my 5,500 pressure altitude with the plus 14 or so. That's probably about right there. Looks like actually probably go one tick mark back. So there's 15 degrees right there, and there's 55 right there, pretty close. And so we can tell I'm doing probably about 112 knots of true airspeed. It's not the most accurate true airspeed calculator out there. It's probably better just to do it on a app on your phone or something like that, but it will get the job done. If you don't want to use it for that, you can just roll it back to a pressure altitude of 0, and then you can see what the indicated numbers are on these missing tick marks down there. The tachometer on the 172 is located below the vertical speed indicator, and it functions pretty much exactly as the one in the 152 did. The only difference is that the limiting RPM is just a little bit higher, and it can go up to about 2,600 RPM in cruise flight. It reacts just like the 152. It overdoes the effect of wind going through the propeller on propeller RPM. So the RPMs when it's static are a little lower than they should be, and they advance a little higher than they should probably when you're in the air. So the VOR radio displays and the ADF receiver display work pretty much exactly as they did in the 152, except that we have downgraded for some reason our nav number 2, so it doesn't have a glide slope display anymore. And the other exception is that nav number 1 can be switched between a VOR radio and GPS course information. We use the nav GPS switch to switch between the two. If it is in nav, which is enunciated in yellow right up there, that means it is hooked up to VOR number 1 and functions just like a normal VOR. If we hit the button and switch it over to GPS, we're now displaying course deviation from the GPS course. We do have to have a GPS navigation point loaded in the GPS for that to work. And if you are in GPS mode, the Omni bearing selector no longer does anything. The rest of the annunciators on here don't appear to function, and the GPS approach button does not appear to function in Flight Simulator 2020. So we have a nice new upgraded audio panel in the 172 that functions much better than the one in the 152. It incorporates a marker beacon system on the top left-hand side. You can switch that to high sensitivity, low sensitivity, and you can put it in test mode, which tests your lights for you. You do have to manually pull that back out of that mode. You have a volume control, but usually these don't work in Flight Simulator. I really haven't tested that one out. You have an intercom control here, which ISO puts just the one person on there. All means you can hear everybody, and crew means you can hear just crew, but obviously that doesn't really serve a practical purpose in Flight Simulator. The buttons for each of the comm or nav receivers are for what you want to listen to. So like if I wanted to listen to nav radio number 1 and see if I've got the right identifier coming in, I press that and I'll be able to hear nav radio number 1, and then when I'm done listening I press it again and it turns it off. We have listen buttons for the marker beacons, for the automatic direction finder, the DME, COM2 and NAV2. They have ICS and aux, which are not used in Flight Simulator, and then the speaker button would route your audio up over the cabin speaker, which is not going to have effect in Flight Simulator. The button or the knob here on the right is your transmitter selector. Really the only practical positions for this are COM1 or COM2. There is no COM3, and Flight Simulator won't let us simultaneously transmit on COM1 and COM2, and TEL is not installed on the Flight Simulator airplane. The transmit light will light up momentarily when you transmit on the radio, so that does function. I'm not going to go in depth in the operation of the Garmin GNS 530 or 430 in this video. That will be a separate video on working GPSs. But since we do have our COM and NAV radios in these units, I'll go ahead and talk about how to change those. We have COM1 and NAV1 up on the 530, and then we have COM2 and NAV2 down on the 430, and both of these work exactly the same. The C button is for swapping out the standby and active frequencies. Just like the 152, you have an active frequency on top and a standby frequency on the bottom. You have a volume control for the COM radio there, and then you change the standby frequency just like you did in the 152. The big knob is the big numbers, the little knob is the little numbers. And then when you get dialed in what you want to listen to in the standby and want to change over, just hit the button to swap them out. In order to get down to the VOR radio to change those frequencies, just push the button that says push CV in the middle, and that'll swap it down to the VOR radio. Same sort of thing, big numbers with the big knob, little numbers with the little knob, and then when you're ready to dial in what you have in the standby into the active, hit the swap button. And then there is a volume control for the nav radio on there as well. Same controls, just a slightly different layout on the 430. One other cool little thing I'll mention that the GNS 530 does when you tune in an active VOR and I believe an ILS, it will actually down below the VOR box, it will give you the VOR identifier. It automatically listens into it and puts up the identifier there, so you don't have to listen to the ID to make sure you've got the right station. And it also gives you the radial that you're on currently, and it gives you the distance. I believe that is DME distance. It is not GPS distance, which you want to take a look at the lesson on DME for the distance, the difference between the two. I'll also mention that even though the COM radios are quite a bit easier to use in this airplane than they are in the 152, I think it's still more efficient to use the ATC menu to use your COM radios, although it's up to you whether or not you want to fuss with the COM radios over here or not. So below the GNS 530 and 4 units is the autopilot. I'll be doing a separate video on the autopilot to go in depth into how the features on that work. Below that you have the transponder. It's a nice digital unit, and we'll talk about how all the different features of that work. We'll actually start right and move left on this one. So we do have the same modes that we have on the other transponder in the 152. Off completely depowers the unit. Standby powers it up, doesn't transmit anything, and it indicates that by saying standby on there. Test just lights up all of our different fields so we can see that it's working. And then on indicates with an on there and is transmitting just our transponder code. And then alt is transmitting our altitude. And we do get an alt to tell us that it's an altitude reporting mode. We get a flight level display right there, which is indicating our pressure altitude. So if you're ever wondering what your pressure altitude is, you can check in that window right there, and that will tell you your pressure altitude. And then we get a little reply light to let us know that we are being hit by radar and sending a reply to that radar inquiry. To enter a code, all you have to do is press the numbers that you want to enter, and that will be your transponder code that's entered. If you want to clear that out, just hit the clear and it will go to all zeros, and if you hit the VFR button, it will send you quickly to 1200. And then you have the ident button right there, which doesn't really serve a practical purpose in Flight Simulator, but if ATC wanted you to ID, that's the way you do it. So it's a nice little unit, and it's a pretty straightforward unit to operate. And again, you want it on or alt for the ATC in Flight Simulator to be able to see and interact with you. Underneath the instrument panel, we still have an ignition switch, which works exactly the same as it did in the 152. The master switch works exactly like it did in the 152. We do now have an avionics master switch that needs to be on to power the radios. Usually you'll turn the master switch on first and then turn the avionics master switch on. If you wanted to conserve battery, if you just want to look at your fuel quantity or something, you can have this off to conserve the amount of time that the battery has on it. Bus 1 controls just the GNS 530, and bus 2 controls everything else. And let's see, the switches down here on the bottom, they're a different type and in a different location than they were on the 152, but they do the exact same thing. Still got pitot, heat strobe, nav, taxi, landing, and beacon. The only thing that is new is we do now have an auxiliary or fuel boost pump. And really the only reason you use that in the 172 is to prime the engine before you start, since it's a fuel injected engine. You generally don't need it on for takeoff or landing or anything like you do in a low wing airplane, because the tanks are above our head. It's gravity fed, and it also has an engine driven pump that feeds fuel to the engine. So the cockpit lighting controls are located underneath the nav radios and to the left left of the throttle and the mixture. There are two knobs on each of these controls. The black knob is kind of an outer knob, and the silver knob is an inner knob, and all of these are rheostats, so you can turn them to brighten and dim the lights that they control. The top outer knob controls the backlighting for your flight instruments, nav radios, and your engine instruments, and it also turns the light that's in the clock and OAT gauge on and off. And the inner knob controls the backlighting for the radios and the GPS and the audio panel. So that's what that does. And then the outer knob on the bottom controls what we call the pedestal light, which is a light that shines down from the roof onto the center pedestal, so it illuminates things like your trim, your throttle quadrant, your fuel selector, and your fuel shutoff valve. And then the inner knob controls a fluorescent light that's right up here underneath your glare shield, and so that controls its intensity. Personally, for me, this is a little bright for night flying, even at its dimmest setting. That's its dimmest setting right there. But if you like this type of light, that's the control for it right there. The parking brake is located in the same place and works the same way as it did in the 152. The trim wheel and the throttle and the mixture work the same as they did in the 152. One new control that we do have here is the alternate static air. We actually have a static port on the inside of the cabin, and this is so that if your outside static port gets iced, if you encounter icing conditions, you can open up this static port and you'll still get static information for the altimeter and the vertical speed indicator, even if your port is iced up. The pitot is heated, so that's why we don't need an alternate pitot source, and you couldn't have one inside the cabin, obviously. But the static port is not heated, so if it gets iced up, we have to switch to a different source. It is slightly off by maybe 50 feet or so when you use the interior of the interior cabin source or the alternate static source, at least in real airplanes. I have not tested that out to see if that's true in Flight Simulator. So to the right of the mixture, we have the flap control, and it works pretty much exactly like it did in the 152. We still have notches for 10, 20, and 30 degrees or full down. And then you have the little indicator that moves to indicate the current position of the flaps. The one difference that we do have on the 172 is now we have two VFE speeds. For up to 10 degrees of flaps, you can put the flaps down at up to 110 knots, but to go beyond 10 degrees from 10 to 30, you need to be at or below 85 knots. To the right of that, we have controls for the cabin air and the cabin heat. And these actuate in Flight Simulator, so you can play with them, but they're not really going to do anything for you in Flight Simulator. So let's take a look at what's over here on the right-hand side of the cockpit. On the top left of this right-hand side of the cockpit, we have a compass deviation sticker. This is not really anything you have to worry about in Flight Simulator. In the real aircraft, because you have radios and other electronic things in the cockpit, the compass is not going to be 100% accurate. So they go out and test it, and they make markings of how far off it is basically from what it should say using ground reference marks. But you can see it's only a couple degrees off for each of the headings. Like if you want to steer a heading of 360, you actually need to fly a heading of 359, and I don't even know that they apply this in Flight Simulator. It may just be for show, but generally speaking, with only a couple degrees off, it's not going to be a huge deal if you don't use that, even if they do apply it in Flight Simulator. To the right of that, we have a ELT, or emergency locator transmitter control. An ELT is a transmitter that if you crash, it will be either set off by the jar or you can manually set it off, and that'll send out a signal that will help people locate you and rescue you and render you assistance. It has 3 modes. It has the test mode. If you flip the switch to the bottom, the armed position is the position it is normally in, where it's about halfway between, and that is the normal position for flight. And really, you don't ever have to adjust this. That's the position it should always be in, and then you can actually turn it on by flipping it up. If you turn it either to the if you turn it to the test position in Flight Simulator, it'll do a momentary sounding of the ELT tone, and then it'll turn itself back off, and then you rock it back up to armed. Normally, in the real aircraft, you'd actually have to turn your radio to 121.5 to be able to hear that signal. You shouldn't be able to hear it just by flipping the switch, but that is what the ELT tone sounds like. And you can also flip it to on, and it'll actuate that tone, but it won't be momentary. It'll keep going until you turn it off, and it'll flash that light there. And in real world, you can actually test these. You want to test them between the top of the hour and 5 minutes after the hour. If you do it in other than that time, people may think it's an actual crash or emergency signal and start initiating, search and rescue efforts. So generally, you don't want to do that outside of that time period in real life. To the right of this, you have a carbon monoxide detector. I'm pretty sure this is just for show. In the real world, if you detected carbon monoxide, this center orange part would start to turn black, and that indicates you've got carbon monoxide in the cockpit. But again, I think it's just for show in Flight Simulator. And then the bottom of that, you have a Hobbs meter. I believe we had one of these in the 152. It just shows you the time that the airframe, or that the engine's been running, and it will count up in hours and tenths of an hour. To the left of the Hobbs meter, you have the automatic direction finder, or ADF. I have done a video on how to use ADFs and NDBs. ADFs are in the aircraft, and NDBs, or non-directional beacons, are on the ground. If you'd like more details on how to use an ADF or NDBs, I will put a link to that video in the video description for this video. But we'll talk about I did talk about in detail how it works in that video, but we'll go over the functions here real quick. It is a digital ADF, which is kind of like having a digital record player, but hey, whatever floats your boat. The ADF switches it between ADF mode and antenna mode. This is just different ways that it receives and different antennas that it receives on. In Flight Sim, it really doesn't matter which mode that it's in. The BFO mode will put it in BFO. The BFO mode button will put it in BFO mode, which is a beat frequency oscillator. Again, it doesn't matter which of those 3 modes it's in. They will all receive the same in Flight Simulator, regardless of which mode you have it in. The frequencies are just like your comm radios. You have an active radio, or active frequency on this side. You have a standby frequency on this side, and your big or your small knob here controls the little digits. And then if you press the small knob in, it will then control the 10 digits. And then the large knob controls the first 2 digits, and it rolls from, whoops, wrong knob there, rolls from 17 all the way back to 1. That's the range of frequencies you can get. And then to flop out the frequencies and put the standby in the active, just hit this frequency swap button, and it goes right over. It also has the feature of having a flight timer. If you hit the flight ET button here, that will display your flight timer. It tells you there's a flight timer right up here, FLT. And this tells you basically the time that's elapsed in minutes and hours from the time you have started your sim session. So I've been here about 40 minutes right now. And you can also hit that again, and it will give you the elapsed timer, ET. And to start this clock, you hit the set button, and that will start it running. Initially, it does seconds and minutes, and I believe it eventually flips over to minutes and hours after a few minutes. But you can use this to time things like approaches if you want to use that. To stop it, you just hit that button again, and then if you hit the button a third time, it will reset the clock. If you want to get back to having the frequencies displayed here instead of the timer, just hit the frequency swap button, and that will bring the frequencies back up. It also has a volume control knob. Like most of the volume control knobs, it doesn't really seem to do anything, but if you rotate it all the way to the left to off, it will turn the unit off. So most of the fuel system controls are located on the floor between the two pilot seat on the pedestal here. So we're below the trim wheel and the hand microphone. And here's the mixture and throttles right up here. The first control that we'll look at is the fuel shutoff valve. You can't see it very well in Flight Simulator because it's kind of hidden behind this mic cable, but it's this little red knob right here. When you can't see it, that means it's pushed in, and that means that the fuel shutoff valve is open, and that is the normal position for all operations. And then if you pull it out, that shuts the fuel shutoff valve off. That closes a valve from the tanks to the engine. It will burn. The engine will burn what fuel is left in the lines, and then the engine will cease to operate. Obviously, the only time you would want this in the off position is if you are on fire or you're conducting an off or airport emergency landing. So the normal position for that is going to be in or having the fuel shutoff valve on. You also have a fuel selector control here. It has three positions, burning from the left tank, burning from both tanks, and burning from the right tanks. And the normal position is to have it positioned to burn from both tanks. It will burn fairly evenly from both tanks if you do that. Really, the only reason you would have this positioned to the left or right tank is if you suspect that you have fuel contamination in one of your tanks and not the other. You'd want to burn out of the tank where you know you have good fuel. It's also possible that you could be burning unevenly. For some reason, maybe it's draining out of one tank faster than it's draining out of the other, and you could drain out of the heavier tank. But really, in Flight Simulator, there's no reason to have it on anything other than both. As far as the brakes and the rudder pedals, they work pretty much the same as they did in the 152. So let's take a quick look at the difference in the systems between the 172 that has the steam gauges and the one that's equipped with the G1000 panel. Again, I'm not going to go into a lot of depth about how the G1000 works. That will be a separate series of videos, but there are a few minor systems differences between the aircraft that are G1000 equipped and the traditional aircraft. The first thing that you'll notice is that with the G1000 equipped aircraft, in addition to having a primary aircraft battery, we also have a secondary battery, which they call the standby battery. The reason we have this is so that you have enough electrical power that if your alternator fails, you can still power at least one display and its associated navigation equipment like one VOR radio and still have that available to you for at least 30 minutes. And the controls for the standby battery are located just to the left of the primary flight display or the PFD. It is a 3-position switch. If you bring the position down to the test switch, it will make the test light illuminate green. And the procedure for that is to hold that for at least 20 seconds to make sure that you have a good standby battery before you turn anything else on. That is a spring-loaded switch that will snap back to off once you release it. And then the procedure in this model, the 172, is before you turn on the normal master switch, you're supposed to turn on the standby battery to arm, and that will power up the primary or the PFD, and that will show you that you have a good battery that's able to take the load and power that PFD before you turn on the regular battery with using the master switch. Another difference between the aircraft is that our cockpit lighting controls have been moved over to the left side here. We have 4 cockpit lighting controls. The upper left one controls the back lighting for kind of this area over here for your lights, your standby battery controls, your circuit breakers, and the magnetos. And then the right upper control controls the back lighting for your standby instruments. And then the pedestal lighting still controls the light down at the pedestal. So this turns on a light that's down at the bottom that shines on your fuel selector and fuel shutoff valve. And then the avionics actually controls the dimness and brightness of the actual MFD and PFD screens. The exterior lighting controls and other switches are located to the right of the cabin lighting controls, and they're pretty much the same as they are in the other 172. You have a beacon, landing and taxi light, nav light, and strobe light, and then on the bottom you have your non-light switches. So you have the fuel pump for priming the engine, and then you have the pitot heat, and then the third switch is a control for turning power outlets in the cabin on and off, and obviously that's not going to be a lot of use to you in Flight Simulator, and that switch does not work in Flight Simulator. The rest of the differences are relatively minor. The biggest of the minor differences is that we do have 3 standby instruments down below the MFD and kind of the center area of the console here. This is so that you have a traditional airspeed indicator, an attitude indicator that's powered by a vacuum system, and an altimeter. And this is so that if you lose complete electrical power, you will still have enough instruments to keep the aircraft right side up and control the aircraft. Even though you won't have any navigation capability, at least you'll still be able to control the aircraft. And then we have magnetos are basically the same place and do the same thing. You have a lot more circuit breakers because we have a lot more electrical equipment, but we can't do anything with them in the flight simulator. Alternate static port or alternate static control has moved, but it basically does the same thing. The throttle and mixture at exactly the same place. The flap handle is the same place and does the same thing. Cabin and heat control, air and heat controls are basically in the same place and are still just as non-functional as anywhere else. And the ELT control has moved, and it's a 2-position switch. It's either on or arm, so if you want to hear it, you got to flip it to on. And then we have a Hobbs meter over here. We still have the same trim system, still have that microphone that doesn't work. Then you have the fuel shutoff valve, and you can actually see it here. They've rerouted the cords, so you can actually see what it looks like now. And then you have the fuel selector down here at the bottom, works exactly the same as the other model. Rudders are in the same place, and the parking brake is in the same place. So that is all the differences between the 172 G1000 model and the traditional classic or steam gauge model. That concludes this video. As always, if you've enjoyed the content, please don't forget to like, subscribe, and ring the notification bell. Be on the lookout for a video series on the G1000 and a flight checkout in the 172 on this channel in the near future. Thanks for watching, and we'll see you next time.